In this video, we're going to have a look at vector journeys in 2 dimensions. These are sometimes referred to as vector pathways as well. Vector journey or vector pathway questions will give you a start point and a finish point, and it's going to ask you how do you get from the start to the finish in terms of some vectors. Okay, here we've got a diagram showing a parallelogram where we're told that the journey from O to A is given by the vector A, so that's the name of this road in that direction, and the name of the journey from O to C, the name of this road in this direction, is given by the vector C. Before we go ahead and do this question, one really important fact is to know that parallel lines are named by the same vector. Okay, parallel lines are named by the same vector. Because if I ask you to draw a vector that's 2 along, 1 up, then I ask you to draw another one that's 2 along and 1 up, those two vectors will be parallel. Okay, so see, in a parallelogram, the opposite sides are parallel, hence the name. So this line is parallel to this line. So if this journey from here to here is called A, that means that this journey from here to here is also called A. From O to C, that's parallel to A to B. So if this journey is called C, this journey will also be called C. Okay, let's have a look at the question. Write the following vectors in terms of A and C. So we want to work out, how do I get from A to B? What's the name of the road connecting A to B from A to B? So I go from A to B, and I can see that that road is named by the vector C. Okay, let's have a look at the next one. From C to B, starting here, I'm going in this direction. I know the name of that road. That road is called the vector A. For part 3, I want to go from B to C. So I'm going from here to here. I'm going in the wrong direction. I'm going backwards along this vector. Okay, I'm essentially reversing down this road. So although this road is called A, because we're going in the other direction, the vector will be minus A. Okay, let's have a look at the fourth one. We want to go from A to C. You get a few routes here on how you want to do it. You could go, I'll maybe do this one up here for part 4. C to get from A to C. You could go first from A to O, and then from O to C. Yeah, I'm saying to get from here to here, you could go from A to O and then O to C. If you were to do that journey, A to O, we're going in the wrong direction, so that's going to be minus A. And then we're going O to C, so that's going to be plus C. Okay, that's one possible option, or you could have went the other way. For A to C, you could have went from A to B and then from B to C. A to B is a vector C, B to C is a vector minus A. You will notice that these are both the exact same. Minus A plus C is the same as C minus A. We get the same answer. How you take that route is irrelevant. The journey you take is irrelevant because you'll still get to the same answer. A wee aside here is, now that we've got that, we now know that this dashed line here, I now know the name of that road. That road is now called minus A plus C. Okay, I'm going to rub that out just now because we're just stuck with the parallelogram lines. Okay, part 5, we want to work out how do we get from O to B. To get from O to B, we've got a few different routes. We could go to A then to B, or we could go from C then to B. I'm going to go from C to B because that means I'm going in the right direction of the vectors. Actually, it's going to be perfect either way. So we're going to go C plus A. Or you could have went the other way and had A plus C. Lastly, how do I get from C to A? You've got a few different options here. You could go to B and then backwards along this line, or you could go back along this line, then up to A. I'm going to go up this line here because I know the name of this road, so that's going to be A, and this is minus C. So my journey here is A minus C. Okay, this is just a few basics here. We're going to introduce something else now. So we've got the exact same parallelogram, but then we're told here if X is the midpoint of AB, so in the middle of AB, there is a point X, and in the middle of BC, there is a point Y. Find the following in terms of A and C. Okay, so we'll try and work through this one a little bit quicker. So we want to go from A to X. Well, C from A to B. A to B is the vector C, yeah, because it's parallel. But X is halfway along, so we're going halfway along the vector C here. So A to X is 1/2 of the vector C. From O to X, we're starting here and we're going along to here. So that means we're going along the vector A, and then we're going halfway along the vector C. How do we get from C to Y? Well, if we recall that from C to B, this is the vector A, because it's parallel to this, so if this is A, this is A. But Y is in the middle of it, Y is halfway, so from C to Y, that's going to be 1/2 of the vector A. How do we get from O to Y? Well, we're going to start at O, we're going to go along to C, then up to Y. So this journey here is called C, and then this bit here is a half A. So it's going to be C plus 1/2 A. Finally, how do we get from X to Y? How do we get from here to here? Well, if we recall, try and do this in red here. This vector in red is given by the vector C, but we're told that this vector here, or this point here, is in the middle. So C to get from X to B, we've still got a half of C to go. That's going to be 1/2 C. And then we want to go from B to C. I'm going to do this in green this time. So this vector here is the vector A, the full way along. But we want to go from B to Y here. So we're going backwards along this, and we're only going half the way along. So it's going to be minus 1/2 A. Okay, one final example. The shape in the diagram shows the vectors A, B, and C. Here they are, A, B, and C. M is the midpoint of AE, so M is the middle of AE. Find each of the following in terms of A, B, and C. Okay, so a few wee things. I notice I've got a vector A here and a vector A here, therefore these two lines must be parallel. Let's have a look. How do we get from A to E? We can only go along roads that have got vectors that we know the name of. There's not an arrow here, and it's not parallel to any other sides, so I can't go directly. So if I want to go from A to E, I'm going to need to first go from A to B, that's the vector A, then from B to C, from C to D, and then from D to E, which is the vector C. Okay, and we can simplify this just like how you collect like terms. This is 2A plus B plus C. Okay, because we were going in the direction of the arrows, didn't need to worry about any negatives there, but we could collect our A and our A to get our 2A. That means that the journey from here to here is given by the vector 2A plus B plus C. So the question is, what is, for part B, name the following vector. How do I get from A to M? Well, now that we know our answer for part A, I know that M is in the middle of it, so I need to go halfway along that vector. So it's going to be halfway along the vector 2a plus b plus c. Okay. How do I get from b to a? I'm starting at b, I'm going back along this line, back to a, so I'm going in the wrong direction, I'm going in the other direction of the arrow. Okay, so it's going to be negative a. How do I get from m to d? Okay, so we're starting at m, and we're going to go from here up to here. We could go this way as well, we'd get the same answer, but we'll try and take the most direct route. So m is halfway, so we need to go this half along. So we've still got a half of 2a plus b plus c. And then that takes us to this point here. We then need to work backwards towards d, so we're going in the wrong direction. We're going in the other direction to the arrow, so that's going to be minus c. Okay. You would probably be expected, I'll just put a wee start, you'd be expected to simplify this, because we would have, if we were to multiply out a bracket, we would get a plus a half b plus a half c minus c, and then we can collect our c's together. That's a plus a half b, then we've got a half minus 1, which is minus a half c. So that is MD. Okay, finally, how do we get from C to M? Okay, well, from C to M, we're going to go, there's 3 different routes here. Where will we go? You could go backwards to B, backwards to A, then halfway along, or you could go on to D, on to E, then back this way. I'm going to go on to D. Okay, so that's going to be A plus C, and that will take me to this point here. Then to get backwards, I need to go back, so I'm going in the opposite direction. So it's going to be negative, and I'm going halfway along. So it's minus a half of 2a plus b plus c. And I'll just take my working up here. So from C to M, you'd be expected to simplify. We would have a plus c minus a minus a half b minus a half c. So my a's would simplify. I'm going to be left with minus a half b plus 1/2 c. So essentially, what we just worked out there is if we were to take a direct route from here to here, then I have the name of that road now. Okay, hopefully that was helpful, and it'll help you tackle some of these questions. Thanks very much.